Hello and welcome back to another video series. Now we will look at the topic 2, which is the algebra. So we will discuss what is algebra. So the algebra can be defined as is a branch of mathematics that deals with what is called the symbol and the rules for manipulating those symbols. Basically, it is all about finding the unknown values and expressing the relationship between those quantities. Example, we talk about the variables such as x and y. And those variables x and y, they hold a value. And this value can represent a quantity. And when we talk about the quantity, that means anything that we can measure, such as the length, the volume, the temperature, the time. All of these can be regarded as a quantity. And those quantity can be represented in terms of the variables, such as x and y. And you might wonder, why using the variables as a symbol? Well, we can see that the variables allow mathematician to generate pattern and solve problem systematically, and to understand real world scenario. When we talk about the real world scenario, we are talking about the event that happens, and this event can be measured. So those variables, they normally help mathematician to solve this problem systematically. We will look at some example, and from there you would appreciate why do we use variables to solve problems. The example we can look at is with respect to a voltage, a current, and the resistance. And we can see the relationship such that the voltage is proportional to the current times the resistance. And now this V represent the variable, and I represent also the variable, and R also represent a variable. And this variable R holds the magnitude of the resistance, and the unit is in terms of the ohms. Similarly, for the variable I, which represent the quantity, which is the current, and we can measure the current, and the symbol is given as the amps. And for the voltage, we can see that the variable is given as V, and it has a unit of the volts. Now, if we want to see the relationship between the voltage, current, and the resistance in order to analyze a circuit, for example, systematically, we know that in an electrical circuit, we can have a voltage source, and we have the resistance, and we have the current which is flowing through this resistor, and we have the V here. So we can see that this electrical circuit is mathematically defined as an equation, and we can write this equation such that the voltage is equals to the current times the resistance. We don't normally write the name as voltage equals current times resistance. However, we use the symbol, and this symbol is a representation of a variable. So when we want to deal with such an electrical circuit mathematically, we use the symbol. And also, if we want to understand the pattern, then whatever value that we measure can be shown in a graph. And we can see voltage, current, and the slope of this graph will represent a resistance. And in this video, if you want to understand why algebra is important in science and technology, you can watch the video series to the end, and by then I guarantee you will be able to fully understand why mathematics is important in dealing with real quantities and solving real world scenario and its problems. And to motivate you, we can simply say the voltage is equivalent to the product of the current and the resistance. And we all know that when voltage decreases, the current will decrease. And the variable R is mostly constant in an electrical circuit. If we want to show the relationship, if we plot something like this, and we can represent this by a 1 kilo ohm resistor. And what will happen in this graph? This graph will represent 3 kilo ohm, and we can say this graph here will represent 7.5 kilo ohm, and this region can represent 20 kilo ohm. So what is the relationship in this graph? We all know that the voltage is increasing in this direction, and we said that increasing the voltage will also increase the current in the y or the vertical axis. Now when we consider the current, for the current which is 1 kilo ohm, when we have a 1 kilo ohm resistor in an electrical circuit, we can see that it is mostly linear to the graph. Although all of the signals are linear, we can say that if the resistance is less, we can plot by saying from this point all the way to this point. And we all can see that if we say that the voltage is in this region is 10 volts, and we can say we have 20 volts and so on. And when we have the current which is 1 kilo ohm, we can now determine the value of the current in this region. So let's see, the current will now equals to voltage divided by the resistor. And if the voltage is 10 volts divided by 1000 ohm, now we can have 1 divided by 100. Now will give us the current which is equals to 0.01 amps. That means if this resistor is 1000 ohms and this voltage is 10 volts, the current that is flowing through the circuit is now 0.01 amps. And what will happen in this region? At this point where we have 10 volts and 3 kilo ohm resistor, we can substitute into this equation such that 10 volts divided by 3000 ohms. Now we should have 0.00333 amps in this circuit. So in this region we can see that 0.0033 amps in this region, and previously it is 0.01 amps. And what will happen in this point here? We have 10 volts which is connected in the circuit. What will be the current flowing in the circuit? Now we can have 10 volts divided by 7500 ohms. So we should have the current in this circuit is equivalent to 0.00133 amps. And we can plot in this region 0.00133. And finally, what will happen in this region? We can see that 10 divided by 20,000 ohms. Now we should have 0.000333 0.05 amps. So we can write here 0.0005 amps. So from this order of the graph, we can see that the current decreases when we increase the resistance. And this shows us the relationship of this particular electrical circuit. When we increase the resistance, now the current will decrease. And when we decrease the resistance in this direction, you will see that the slope of the graph will increase. And when we increase to a certain point in here, we increase the current in this region and increase the resistance with the slope, we can see that the voltage will now be increasing. So we can see from this relationship that we normally use algebra such as representing a signal in terms of a variable. So it is very easy for us to compute the relationship between those quantities, such as decreasing the voltage will decrease the resistance and the current, and increasing one or two of these variable, we will have the change in the other variable, such that if we say the resistance is equals to voltage over the current, in this case, what will happen to the resistance? If we increase the current, that means the current flow in the circuit is increased. That means it is inversely proportional to the resistance. So that means increasing the current, meaning the resistance in a circuit is decreasing. So this will motivate you to learn what is an algebra, because in the future when you study advanced system, you will mostly use maths to cover the scenario and the computation of those values in those parameters. And in this course, we will basically look at one, which is the introduction to algebra, where we will look at the variables, the constants, and the expression. So why you would want to know what is a variable, what is a constant, and what is the expression. And we can look at evaluating algebraic expression. And the second subtopic, we are going to look at the basic equation. So equation is nothing but if we say x plus y is equals to z, now this represents the equation, where the equation has variables and the basic operators. And we can look at the Cartesian plane and the plotting points. And also we are going to look at the slope of the graph, which is represented by m, and the intercept. So in a graph, we normally have a slope and the intercept. And we will look at the point slope, form, and the standard form. And that subtopic, we are going to look at the linear equalities. So why linear equalities are important in terms of solving and graphing on a number line. So we all know a number line is nothing but a plane which we can have 0 and all the positive numbers and the negative numbers. For example, 1, 2, 3, 4, minus 1, minus 2, minus 3, and towards minus infinity, and this one towards the infinity. So this can be our number plane. And when dealing with analysis, most scientists, most mathematicians, most designers, they use a number plane to represent the values or the outcome of the research, and they use number plane to show the relationship between the quantities and the measurement. And we can look at the compound inequalities and the system of inequalities. And the fourth, we can look at the polynomials and the factoring. And fifth, we can look at the rational expression and the radical. And sixth, we will look at the function and the graph, how mathematical functions are related to the graphs. And we can look at number 7, which is the exponential and logarithmic function. And finally, we can look at some of the advanced topics in algebra. So when we come to this stage, I will briefly explain what do we need to learn in each of these subsections. But for now, we will start from the introduction, looking at the basic equation and the linear inequalities in the algebra. And now we will look at the variable, similar to what we discussed previously. A variable is nothing but a symbol, and it is represented in alphabets such as the X, Y, A, B, N, M, and all of these represent the unknown or a changing value. So when we talk about a variable, it describes a unknown value or a changing value, and it depends on the situation. And the term constant, when you hear the word constant, that means a fixed value. A fixed value in an equation that does not change. And it can be a number or a symbol. And this number or symbol, they do not change. So they are fixed and we call it the constant. And finally, we talk about the expression. So expression is defined as a mathematical phrase similar to English phrase. This mathematical phrase combines the variables and the constant and the operators. We learn the basic operators such as the addition, subtraction, multiplication, and the division. Now we can look at this mathematical phrase. Example, you can have y is equals to 3x plus 4. Now we can see that this represents the expression where it contains a constant term and we have the variables and the variables. And from this expression, you can think of it in such a way that the variables are flexible, meaning they can change, while the constant, they stay put or does not change. And the expression put the variables and the constant together in a single basket. This now brings us to the conclusion where we define what is a variable, what is a constant, and what is the expression. Remember that the variables are the changing of the values and the constant is a fixed value and the expression is a phrase of both the variables and the constant. And we can see if the x changes, then the y changes in this phrase. However, the constant will not change. When we substitute x is equals to 1, then y will be equals to 7. When we substitute x is equals to 2, y will be equals to 10. And x is equals to 3, we have y is equals to 12. And whenever x changes to infinity, y will also changes to infinity. This is the basic representation of the algebra. When you understand the variables and the constant in an expression, it is now easy for you to solve the unknown. And to find the relationship between the two, we can plot. If we are to plot this value, if we have the y and we have the x, when we have x is equals to 1, 2, 3, 4, 5, what will happen? So we can have y, we say we can have 3, 6, 9, and 12. To see the relationship, if this graph represents y equals to 3x plus 4, now when x equals to 1, that means in this region, what will happen to the value of y? The value of y will be 7. So this is the point on a graph, and it tries to give us a relationship between the variables. And when x is equals to 2, what do we have? We have the value y is equals to 10, and when we have the x is equals to 3, we say that the value is 12. So from this expression, we can see a linear relationship that exists. And in terms of a slope of a graph, we have the equation y is equals to mx plus c. Later on, we will talk about the slope of the graph, and the c represents the constant or the y-intercept. That means a line that cut through the y-axis. So it should be around here. And if we now want to draw the relationship, it should be a linear line like this. So it is very important for you to learn algebra such that you can compute the changing values, and then you can show it graphically by plotting it into a graph to see the relationship. Therefore, from the expression, we can summarize that we have a constant and a variable which is changing, and by analyzing the variables which is changing, we can be able to find the relationship. And if we have a system, given that we have input x and the output y, and we have the beta, which is the gain of the system, to represent the system, we can come up with the expression such that y is equals to beta x. Now, this is our expression. And we can say the beta is our constant term. If beta is equals to 2, now we can find when x is equals to 1, then y will be equals to 2. When x is equals to 2, y will be equals to 4. When x is equals to 3, y will be equals to 6. So we can also see the linear relationship between the input and the output of a system. So we can see that this expression represents a constant term and a variable term. And we can also plot this relationship on a graph such that we have the x, we have the y. We can have 1, 2, and 3, and we can have 2, 4, 6. Now we can see that when x equals to 1, which is the 2, when x is equals to 2, we have 4. When x is equals to 3, we have 6. And when we say x is equals to 0, what will happen to y will be equals to 0. Now we can also plot this relationship, and we can say the relationship is linear. And from this we can see the importance of why do we need to learn such algebra, because this algebra at the end of the day it represents the system under consideration. If you like our video, you can kindly subscribe and share this video with your friends so they can also learn the importance of learning mathematics. And you can appreciate that we have the operators in an expression. And because of this operator, we all know that the constant and the variable, they represent a signal. And those signals have a magnitude. If we are to consider, for example, the x-axis represents the voltage and the y-axis represents the current, then current and voltage, they are an electrical signal and they have their own magnitude. So it is not only learning the variables and the constant, but they represent a quantity that needs to be measured. So I hope in this video you can now understand what is the importance of learning the algebra, the variable, constant, and expression, and evaluating algebraic expression like what we did here. So any mathematical representation, they have their own expression. And when you see those expressions, you now should be able to appreciate that they are the algebra that is used to represent different phenomena in a real world scenario.